Hello, everyone. Our speaker today is LVH. His beard solves discrete logs in fields of small characteristics, and he's going to be speaking about building secure software. Please welcome him.
Hi, thank you all for coming. So I'm going to be talking about building secure systems, building secure software in the particular. So I'm LVH, that's my Twitter handle. If you want to email me, it's anything or an underscore at lvh.io. The slides are already up. I'm going to be showing this link again in the end, but it's just www.lvh.io/building secure software. Quick introduction. So hi, I'm LVH. I'm a cryptographer. We're at PyCon, I'm sure you've gathered. PyCon is a very special time of the year for me. There's a lot of friends that I only get to see about once a year, and PyCon is that. This year at PyCon, I have 2 talk slots and a couple of staff positions, including financial aid, which is the non-trivial work of distributing about $250,000 to about 330 people. That's not bragging, that's an apology in advance. I'm running on a significant sleep deficit. If, with any luck, I'll be somewhat coherent. I have a day job. I work at Rackspace. It's a really cool place to work. We're a sponsor. You should go to the booth, talk to us. In this talk, I have some bad news, I have some good news, and I'm going to have a meta conversation. I'm going to talk about the conversations that we have. Not in this talk are common security bugs, the importance of software updates, or what software to use, or stuff like that. So it's fairly high level, fairly abstract. It's fundamentally about the human interactions that end up producing software and systems. So the problem is actually fairly simple. All software has bugs. Some of those have security implications, and security bugs are bad. I think we can all agree with pretty much all of these statements. That sounds very pessimistic, but this talk is really a message of hope. I'm not suggesting that we give up. I'm not suggesting that we try to attain perfection, because it's probably not going to happen. But I am suggesting that we can do significantly better as an industry, and that more importantly, we have to do significantly better as an industry. So, unfortunately, I got to start with the bad news. And quite frankly, there's absolutely no wonder that everything is broken all of the time, because there's just so many reasons. Most of our tools that we use for developing software generally don't really work when it comes to security. A lot of corporations mess it up. Our education system fails to educate. And trust me, this is not a complete list. It's very, very easy to find different subtle ways that stuff is broken and why it's broken. Now, I mentioned that our tools don't work. So, somewhat facetiously, how do I write the unit test for security, right? How does that work? What does that look like? You can't actually do that. So ask yourselves, how do we learn software? If there's some new software package that I'm interested in and I want to learn how it works, how does that happen? Usually, we read the documentation, right? Hopefully. And the problem with most security documentation is that it's like missing or terrible. Missing is actually the better option, because most of the terrible docs just like mislead you and you think you're doing it right and you're not. The other problem is Google and Stack Overflow. Now, I don't want to rant on Google or Stack Overflow. They're wonderful tools, but the problem is that they have lots and lots of misinformation. The other problem, and this is going to come back numerous times, is that good practice looks exactly like bad practice. And to most of us, it is usually indistinguishable. So how else do we learn, especially when there's no documentation, right? You play with it. You install it, you look at the code, you open up a Python REPL, you create some objects, you have a good time, usually. And then you learn something and you repeat the process. And eventually you learn enough about the stuff that you're using, and yeah, it's a good time. Fortunately, security doesn't really work that way. For virtually everything related to information security, when you do the install it, play with it step, then the next step is generally get it wrong. And then you repeat it anyway. And the problem here, I'm not saying like, you're all dumb. You're all going to get all security stuff wrong. No, that's not what I'm saying. What I'm saying is the docs are terrible. This is really tricky. And doing it right does exactly like doing it wrong. So it's not your fault, but that doesn't mean it's correct. It does almost work that way. So one of the best ways to learn stuff about information security is to try and break into systems. And there are people and companies that do this professionally all of the time. So what you could do is you can install some software, try to break it. You'll probably learn something, and then you repeat. And usually after you break something, hopefully you fix it as well. But But the problem is that we're generally not trained to think that way, right? Your job as software engineers is to make something work, not to make something fail. The other problem is that failure is significantly harder, right? There's usually only about one way that something can work correctly, and there is basically a left null ways that something can work, something can fail. The issues are significantly more subtle, right? You're not testing the happy path that it does that, this thing parses something correctly. You're testing if an attacker actively tries to get me to parse something incorrectly, what could possibly go wrong? The answer is lots. Also, we're not really paid to think that way, right? So out of all the people in this room, who regularly writes software? Right, so for those on video, that is everyone. Who regularly gets to do pen testing? Who regularly actually gets to, okay, so that's like maybe 5 people. Let's be very generous. There's very bright lights. Let's be generous. A dozen, right? There's a lot more than a dozen people in this room. So we don't get to do that on a regular basis. And another problem is that a lot of corporations mess it up. Somewhat understandable. New features are obviously more interesting than fixing existing security bugs. People make mistakes. This is simply human nature. This is going to happen. And when you don't spend an awful lot of effort into trying and prevent it, some people are going to make mistakes and they're going to hit production. And again, good practice looks just like bad practice. So it's not like these things are easy to spot, especially if you're not a trained information security person who basically has devoted large parts of their life to spotting these things. Another thing is that a large publicly traded company, which will not be named, I'm not trying to pick on any particular company. The reason I picked this one is because they had very public, very mediatized, very visible, several security incidents. And so, for example, there was a particular incident, the PS3 key leak, that involved getting a very basic crypto primitive completely wrong. Then there was another large leak where a bunch of information got leaked. Now, if you look at, this is the market cap of said company. The black line is the 0 line. You'll notice that these are not company-ending events, right? So you could argue that from a purely market economics perspective, these companies are being entirely rational actors because turns out you can totally get away with it. Another problem is abstinence-only education. So what do we teach? For those of you who would think that, or consider yourself to have had formal CS education, so like AP classes, or you took a couple of CS classes in college, right? How many of you have heard of Liskov substitution? A lot. I don't know if that's a global thing, but for most of the people that I've talked to, and that includes myself, basically nobody lets you write the word class into a text editor without having talked to you about what Liskov substitution is. Now, Liskov substitution there's some formal logic there. Basically, it just means that if you have a widget, you can always replace it with a widget of a subtype of the original widget, so you can always replace things with their specializations or their subclasses. And like this is apparently very important because this is the first thing people talk about. Now, what don't we teach? Least authority. This principle that you don't give people, that you don't give stuff more power than it needs. Very simple example, a lot of us write Python. Every single Python function, every single piece of Python code that you call can basically do whatever it wants. It can open files, it can read stuff, it can, calling some C looks exactly the same like calling some Python, who knows what that's doing. So we really bestow a lot of authority upon things that aren't very well authenticated. Now, this is where I do the extensive hand-waving bit. I don't mean to hate on the Liskov substitution principle. It is a perfectly valid piece of computer science. I'm definitely not hating on Barbara Liskov. She's, without a doubt, one of the greatest computer scientists to ever have lived. That is not my point. What I am saying is that as an industry, we would be significantly better off if we stopped talking so much about, whenever we said Liskov substitution principle, instead we talked about the principle of least authority, I think we'd be in significantly better shape. This is particularly true for an industry that is increasingly servicing the needs of a huge amount of people. And increasingly, the services that we provide are increasingly great. You should go to Glyph Lefkowitz's talk. He's going to talk about the ethics of all of this, but that really ties into the same thing. So the bottom line is that security is not a priority. It's not in business, it is not in education. So therefore, don't be a jerk to your peers about InfoSec when they get it wrong. In fact, don't be a jerk about InfoSec. And actually, don't be a jerk. Just like straight up don't. Like, it's generic life advice right there. So there's some good news. Those problems are not set in stone. I mean, education can be fixed. Open source, we can do public education. I've worked for a long time on a thing called Crypto 101. You can download it for free on www.crypto101.io. It's a book that is an introduction to cryptography. There are wonderful Python communities out there, like the cryptography community and PyCon, the PyCon Cryptographic Authority, that spend a lot of time educating people. Maybe someone will fix .edu. I don't know. It's not going to be me. So some tools that we have do actually work, fortunately mostly by accident. So again, channeling Cliff Lefkowitz, he says that programming is nothing if not the act of promoting local understanding. When you apply that to systems, that means that small composed pieces are preferable to large monoliths. And this is a broken slide. So there is no implications here. Note that I did not say that if you use microservices, you're going to be in security happy land. And I did not say that if you're operating a monolithic service, then you're going to have security problems. Pieces could be all sorts of stuff, including functions, classes, and yes, services too. But arbitrary splits can make stuff worse. Another tool that we have, and again, this is not something that is just for security, but can actually really help, is code review. It's basically the best thing you can do for your project after a bug tracker. It allows you to disseminate experience between different contributors, and it helps you cultivate a culture of quality. If you know that your stuff is going to be scrutinized, then probably you're going to spend a little bit more time cleaning it up. Finally, the adversarial approach that I talked about, like the way that you fix systems is break into them mercilessly. This is also the way that you make systems reliable. You get them to fail. You try and get them to fail mercilessly, and you don't stop until you're no longer able to make it fail. You can do that in-house. You can do that with third-party audits. There's nothing stopping most companies, except maybe headcount, from having some people whose job it is to professionally break into their own product. And I mentioned earlier, how do you write a unit test for software? Okay, for security rather. And no, fine, you can't do that, but there is a lot of automated testing that you can do. For example, my favorite example is certificate checking. So basically up until a couple of years ago, and let's be honest, even to this day, basically no software in the world actually checks certificates correctly because it's impossibly hard. It is very easy, or at least it's tractable. Let me hedge that a little bit. To write a test where if you have some software that does some TLS, create a fake server with a fake certificate and assert that your software will refuse to connect to that thing. And then be very, very, very surprised when it actually just totally happily thinks that that thing is Google or Rackspace or whatever. And I mentioned something about corporations messing it up. No, not all corporations mess it up. I know that. Some employers are great. There are lots of great places working for the public good that have teams working full-time, large teams of very clever people. You have security teams at Heroku, Google. I'm probably going to miss a couple. There's lots of great companies. Rackspace is one of them. We have people employed full-time to do this kind of stuff. Unfortunately, this doesn't fix our systemic industry problems. It's helping, but clearly it's not. We're not done, right? So I talked about some good news, talked about some bad news, and now I'm going to talk about the conversations that we have. So channeling another person who's way smarter than I am, Zuko. Zuko's a cryptographer, and he says that security is not about perfect versus imperfect. It is not about better versus worse. It is about this attack surface versus that attack surface. And that immediately means that I have to explain some vocabulary, because attack surface is all of the ways that adversaries can attack the system. So if you think of your system as like a ball, the attack surface is the surface of the ball. It's all the ways that your attacker could potentially get on the inside. The other word is threat model. How will adversaries attack the system, right? Describe how you think that what are they actually going to do to get inside the ball? Now, a lot of security proposals, in my opinion, are basically useless because they don't really communicate what you're about to do. In my opinion, a good security proposal requires a couple of components, including a description, a threat model, a motivation for that threat model, how this affects the attack surface, and how this affects the user experience. Descriptions are actually really important, so you need a very precise description of what you're going to do. I've seen like lots of issue trackers that have something along the lines of, we're going to use secure cookies. I can think of like at least 5 different classes of things that means, And each of those have totally broken and totally good implementations, or at least all of them have broken implementations. And particularly in security, like the devil is in the details. Like there's a lot of things that if you do them slightly differently, it means your entire thing didn't actually work. So it's very important that you have a concrete description of what you're actually going to do, otherwise nobody has any idea what you're talking about. Then you need to talk about your threat model. What are you protecting against, right? What is it that you're actually trying to prevent? When you think about the ball and somebody trying to get in, what is the specific action that is no longer going to be possible? How is this addressed now? Is it not addressed at all? Maybe there's something there, but it doesn't really work. How will it be addressed afterwards? Then you got to talk about the difference in attack surface. The thing is, a lot of stuff is not actually a strict improvement. Think about it. Let's say that you have, so the example here is some monitoring software, right? So you have some software that monitors some processes or something on a server somewhere. Now, that thing requires a lot of privileges, right? Because it has to be able to look at a lot of other stuff. When you add that piece of software, you have to keep in mind, what happens if there's bugs in that software, right? Just because I'm adding something that might be preventing some problems doesn't mean that I'm not also adding something that enables other doors, that opens other doors and enables other problems. And then finally, the user experience, which basically very often forgotten about. I am looking at you, PGP, damn it. And this is actually one of the most important aspects, right? Because, I mean, you could say things along the lines of, well, it turns out we looked at all of the attacks that our company has ever gone through. It turns out that all of them come through a thing called the internet. How about we turn off the internet, right? No, okay, that doesn't work. People need to do their jobs. And obviously, I'm being a little bit facetious, but not really. A lot of us work at companies with fairly restrictive firewalls. Very often, they don't actually fix any security problems, but man, do they make your life hard. To illustrate the importance of threat models, I am going to give you a very simple example and something that I hope that basically everyone here will be somewhat familiar with, smartphones. For a lot of people, smartphones basically contain everything. You know this because your smartphone has your email, and email has everything. Clearly, they need to be protected, right? There's a lot of very, very sensitive information on almost everyone's smartphone. And the way we protect smartphones is with lock screens. And I think we can all agree that no lock screen is obviously worse than any lock screen. Any lock screen, no matter how ineffective it is, it's probably going to be better than no lock screen at all. Now, I have an iPhone 6. It's vibrating a lot. I don't know why. And I have two options, a passcode and a fingerprint. And on some other phones, you have like patterns, quite popular on Android, same thing with face recognition. Now, a pattern is fundamentally a secret, so that's more or less isomorphic to a passcode. Similarly, face recognition, it's biometrics. It's looking at something that you are as a physical person, so it's more or less the same thing as a fingerprint, at least for purposes of this discussion. So which one do I pick, right? I have two options. They're clearly not the same. One is better than the other, right? Okay. So a lot of people instinctively, a lot of consumer, because we have to remember these are consumer-level devices, most people who use smartphones these days are atechnical. So biometrics looks really cool because it's Hollywood-level technology, right? I mean, the last generation of phones didn't have biometrics. This one does, so clearly this is new, shiny, and therefore better. However, biometrics has a lot of problems. I'm not going to talk about most of them in detail, but like one of them is key rotation. Like if I don't like this key anymore, if for some reason I know that there is an attacker somewhere that has my fingerprint, which is fairly realistic, then how do I switch out my key? Like I can't cut off my thumb and expect a new one to be there tomorrow with a new fingerprint. It doesn't work that way. I can't really have separate capabilities. Like, I mean, if I have my thumbprint, that's my way of authenticating for everything. Like, I guess you can have up to 10 or 20 if you count your toes. It gets put on everything that you touch for free, and it is actually totally possible to get fingerprints back off of even pictures, apparently, but especially if you have like slightly greasy hands and you hold a glass of water, guess where your fingerprint just went? Faking fingers is a little tricky, like it is involved. Not every random lowbrow criminal can reasonably break into an iPhone with a fingerprint scanner. But that said, it's certainly not in the realm of the impossible, and there are many, 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 many people that could have access to this for, let's say, a couple $100 maybe. On the other hand, secrets are pretty terrible too. People pick poor secrets, by and large. And even if you pick a really, really, really good secret, keep in mind that we're using smartphones for everything, right? That's what I started all of this with. And if you're unlocking your phone, I don't know, 20, 30, 40, 50 times a day, there's probably going to be someone around that fairly reasonably could see what you just typed into that thing. And as long as it's a secret, it doesn't matter how good your code is. That is, most of the time, like people use something like 1234 or their year of birth or their birthday or anniversary or something like that. So, okay, usually it doesn't even matter. So, we've reached the fork. Which one do I pick, right? I have two different options. They're both not perfect. Like neither of them, both of them have flaws. So how do I know which one's right for me? And the answer is threat models, obviously. Otherwise, I wouldn't start talking about this. And in order to illustrate this, I'm going to talk about the Fifth Amendment. I'm talking about the American Fifth Amendment. I am fully aware that we're in Canada. Start with a disclaimer. I'm not a lawyer. This is not legal advice. Even if you give me money, and I am not suddenly a lawyer. Don't listen to me. This is also not OPSEC advice. I'm merely trying to illustrate the importance of threat models. So without further ado, the Fifth Amendment says a lot of things, but one of the things that it says is that you cannot be compelled in any criminal case to be a witness against yourself. Sorry for the gratuitous gendered language. I did not write it. Basically, you cannot be forced to divulge secrets. Even if you know something, even if you know that you're guilty, for example, in the obvious case, you cannot be forced to say that you're guilty. So basically, you are protected from self-incrimination. It turns out, apparently, I went to the prestigious University of Wikipedia for sources on this, that they can't force secrets out of you of any kind. Passcodes are secrets. Passwords are secrets. This is apparently held up in court. However, fingerprints are clearly not secret. Police can and will take your fingerprint. They do so by default, basically always, if you're arrested, I think it is. By that logic, and this actually went to court, and the judge ruled, yeah, you can totally be forced to unlock your phone. That is how it works. So some person was forced to unlock their phone, and some secrets were divulged. So which one is more secure? Well, it depends on your threat model. If your threat model includes random people, then probably Touch ID, because the odds that you even subconsciously pick a really bad password, especially with a Touch ID, with a passcode, it's only like 4 digits. Shoulder surfing is a real thing. Look, Touch ID is a useful thing, and it fixed some stuff. If your threat model includes law enforcement, which, let's be fair, that includes a lot of people that a lot of people in this room actively support. I, for one, think the EFF is great. Then yeah, you want a passcode, because passcodes, totally a secret. So again, this is not legal or OPSEC advice. I know what happens when you start an iPhone. I'm just trying to illustrate threat models. More importantly, I'm trying to illustrate that if you don't really pay attention to your threat model, you can take actions that arguably improve your security, but are don't even not do anything, but actually make your real security in the places where it matters, make it worse. So therefore, it's really important that you pay attention to what you're protecting against, how you're securing it, and what the effects of your actions that you call securing it actually are. So, to wrap up, like I said, this is pretty much a message of hope, right? We can do this. Even though that we have breaks all the time. Slack got popped, what was it, 2 weeks or so ago. Slack are great guys. Every company has these kinds of problems. Every company is under attack all of the time. It doesn't matter how big or how small you are. It's a big sea with a lot of fish. So we have a long way to go. Most of our security practices are, quite frankly, bad. So that said, we are working on them. We're actively working on them. We have people who spend a lot of time working on them. We have a lot of great companies producing great stuff, both software and hardware. For example, the YubiKeys are fantastic. The fact that it's now reasonable to have every employee have some 2-factor hardware tokens on their lanyards, that's fantastic. That's great. That was outside of the reach of a lot of companies, a lot of startups, not too long ago. And as a whole, as engineers, we can meaningfully impact security. Like, we're doing it already. And the more of you that join us, the better. And you don't actually need to be an expert. Like, obviously it helps, I guess, I'm not gonna lie, but there's a lot of work that needs to be done. There's a lot of stuff that really doesn't require any specific knowledge. It's very easy to, or well, not very easy, but it's possible to train people on the job. And yeah, there's a lot that you can do, each and every one of you. Possibly some of you think that you know absolutely nothing about information security. You might be right. That doesn't mean that a year from now you can't be very meaningfully contributing to the everyday operational security of literally millions of people. And that's all I got. Thanks. I think I have just under 5 minutes. Is that, yeah? Okay, so I wasn't going to take questions, but sure, go ahead. No.
On one of your slides, there was something about having Team A try to break what Team B built. I took that to be kind of a policy of how to get security as a priority for your company and kind of weave it into the process. Was that your intent? And either way, do you have suggestions on how to encourage your company in a successful way to focus on security better?
So that was at least partially my intent, yes. So it is absolutely important, like obviously, especially if you work in a large corporation, for many people, there's very little that they can do without a clear mandate. Like you can't just drop whatever it is that your job is right now and say, like, oh, well, I'm gonna go fix security for the company. Like that's a really good way to get fired. As for how to convince people, like it depends, right? It depends entirely on your company. Like there's obviously companies like payment processors that are going to take it very seriously from day one. Then there's companies where it's like they say they take it seriously, but at the end of the day, other business priorities take over. I think honestly, our biggest ace there is going to be all of these public breaks. They are increasing in both severity and frequency. Most importantly, like they're becoming more visible, and therefore, like basically every CEO now, even for only marginally tech companies, understand that there are people out there who are trying to break into your system and to do bad things with all the data that you have. Everybody knows this. This is getting better and better. This is getting more and more into the forefront. As for whether individual employees, if you're in a big company, it's real hard to convince anyone of anything. The good news is other people are already doing it for you.
Thank you.
Like done, or yeah, okay. Sorry. I'll be happy to take questions either outside in the hallway or there'll probably be an open space that's security related at some point. So thanks for your time.